Well, good morning, everybody. Thank you for joining the Tecplot 360 2023 R2 and what's coming in 2024 webinar. We're going to get right into it this morning. So presenters today, myself, Scott Fowler. I'm the Executive Vice President of Tecplot, and we're joined by Brandon Markham. He's the product owner of Tecplot 360. He's going to be on the line to help address any questions or comments that you may have and help moderate while I'm doing the presentation. Okay, so our agenda today, we're going to do a quick review of the major features that we released in 2023, and the really bulk of the presentation is going to be a focus on what's coming in 2024. Our development teams have been working on some pretty exciting things in Tecplot 360. So that's a preview of what we're calling an alpha of Tecplot 360, which we'll do a solid demonstration of today. And then we are working on an update to the graphics layer in both Tecplot 360 and FieldView. So the 360 and FieldView teams are collaborating on that, and it's exciting to see those two teams come together. All right, so a very quick recap of what we delivered in 2023. These are the major features that we delivered. 2D log plots. So previously, log axes could only be used in line plots, and we've extended that to 2D. So if you have want to do a 2D contour plot with log axes, that is now available in Tecplot 360 and Tecplot Focus. In Tecplot 360, we've also added VTI and VTP loaders in addition to the VTU loader that we already had. So VTI is a regularly spaced structured grid. VTP is typically used for particles, but there are some other cell types that can be held within that data file type. And then VTU is kind of your classical unstructured grids and polyhedral grids. That leaves two VTK loaders that are still yet to be done in Tecplot 360, which are VTR and VTS. And again, those are structured grid types. So if you are a user that would like VTR or VTS, please let me or Brandon know. You can also contact our support staff, support@tecplot.com, and just make that request. It's something that we're willing to do, but we're also trying to find users to test our implementation of those. The really big thing that we released in 2023 are these last two bullets: higher order element support and FE mixed zone type. So high order elements we're seeing really come online more and more. This has been really area of research departments for many years, but we're seeing a few commercial organizations starting to pick up high order elements. So we support P2, P3, and P4 elements from CGNS, SCPLT, and VTU files. So if you need any information, CGNS has a really good set of documentation on the cell shapes, and so that was our first implementation of higher order elements to really support what was available in CGNS. So please take a look at that. And then the FE mixed zone type is a new zone type available in Tecplot 360, and it really allows for much smaller files for a mixed element grid. We have a blog post available on our website that shows just how much smaller a file you can create. There's a data file that we had that came out of CFD++ with classic Tecplot PLT file format. It sat on disk at about 7 gigs, and with FE mixed zone type, we were able to compress that down to about 2.5 gigs. So quite a huge savings on disk, and because you're loading less data off disk, it also loads faster into Tecplot 360, and you can get your work done more quickly. All right, with that, that's the review of 2023 releases. What I didn't mention is lots of bug fixes and minor enhancements, so please do check out this link, features over time. It'll give you a good review of what we've been up to. All right, so let's jump into the Tecplot 360 Alpha. And really what we're trying to do with this is make Tecplot 360 easier to use, particularly for transient data, but also for people with steady state data who want to, say, reuse a layout or a style sheet with data sets that are slightly different. So if you've ever encountered these problems, this build is going to be very helpful to you. So if you've ever tried to save a layout and Tecplot 360 has said, hey, I can't save that layout, you actually have to save your data. This is an untenable situation for a lot of people. Say you have a data set that is 100 gigs or even larger. We have some users who are talking about terabyte data sets, and if you extract an isosurface or extract a streamline, Tecplot 360 will not know how to repeat that that operation and say, hey, I need to save the data, and it's going to save everything. So we're trying to resolve that situation with this new alpha. If you've ever tried to replace data and retain style, this doesn't work with transient data, and sometimes it doesn't work as well due to the next bullet point that we'll talk about. But again, we're trying to resolve this issue and make Tecplot 360 easier to use, easier to reuse layouts and macros for different data sets. So if you've ever had a layout or a macro or a style sheet not work properly because your zones or variables were in a different numeric position, the Tecplot 360 macro language refers to zones and variables by their numeric position, and we're trying to translate to a solution where we're using names, which are not only easier for the end user to read when you're looking at your macro. You can see that you're using the pressure variable instead of variable number 8, so trying to make that easier to use as well. Then if you've loaded a transient data set and have done, say, a data alteration like we see here on the right-hand side, Tecplot 360 will do that data operation over all time steps immediately. And this can effectively waste your time because you might not be visiting all time steps during your post-processing. You might only look at, say, some of the middle time steps. So we're working on an infrastructure that will allow the data processing to happen only at the time steps that you actually visit. And then finally, transient line plots. Tecplot 360 has done a pretty good job with our transient capabilities in 2D and 3D plots. We've always had the ability to animate through line plots, but not in this linked fashion between your XY, 2D, and 3D plots like you see here. So lots of interesting things that are coming down the pipe with this build. So in order to accomplish all this, we're introducing 3 new capabilities or terminologies. One is called the data journal, then deferred data operations, and then something that we're calling part names. And we'll dive into a definition of each one of these here. So a data journal is this GUI component that you see on the right side here. And really what it is it's an executable record of the operations which add, extract, and modify the data. So in this case, you can see that we've added data by doing a read data set. We've altered the data, modified the data using an alter data command. We've done some sort of extraction, some integrations, extracting slices, etc. So this is your data journal. So this provides a record of what you've done. And through the use of the data journal, we're able to accomplish deferred data operations, which means that we are only executing this journal at the solution times that you visit. So therefore, if you only need to look at, say, the middle time step or the last time step in your data set, we're only going to do these data operations for those particular time steps that you visit, therefore saving you time. And then finally, part names. So for those of you who are familiar with Tecplot 360 and have transient data, you've heard the term strand. So a strand and a part are effectively the same thing. So a part is a string value that defines a collection of like zones through time. So in this data set, we have volume data that goes through all the time steps in this data set, and the part name there is called cell data. And we also have a part called piston, and so that represents many Tecplot zones through time. So again, just basically think of a part as a named strand, and eventually we're going to try to devalue the strand concept and replace it with parts, but this is going to take a little while to do that migration from one to the other. All right, so nothing's better than a demo to give you a good idea of what this all means. So let's jump into a demo. I have a couple of data sets that I want to show, and they'll highlight each one of these capabilities that I've talked about earlier. So in this first demo, I want to show a couple of capabilities such as linear interpolation and extracting slices, and then in this case also transient line plots. So what we're going to do is we're going to go through the steps to recreate this layout. So let's start from scratch, and we'll load the data. Now, this data set has 72 time steps in it, and you'll be able to see how the deferred data operations works as well. Let's just do a little rotation of the data to get it back in that same position that you just saw. And the first thing that I want to point out here is this data set does not have any pressure values on the wing, but if we drop in a slice, we can see that we do have pressure values in the volume. So what we want to do is do a linear interpolation from the volume to the surfaces in this data set. So we'll go to Data, Interpolate, Linear. And if you've ever used this dialog in Tecplot 360 before, you would notice that for a transient data set that you would have hundreds of zones listed in here. So if I needed to do this linear interpolation in the existing version of Tecplot 360, I would effectively have to do 72 linear interpolation operations, because this dialog exists in the current 360 2023 isn't transient aware, let's say. So in this case, we'll interpolate from the volume zones to the surface zones, and we'll just hit interpolate once. And you can see that we now have contours on our surface, and we have a data journal command that shows exactly the operation that we took. Let's turn off the slice, and let's say, well, in this process, I know that I really only need to do the linear interpolation on the wing surface, and so I can save myself some time by editing this command. I'm going to select just wall 9, hit apply, and it re-performed this data journal entry, and you can see that we now no longer have pressure values on these other surfaces. All right, so the next step we want to do is we want to extract a slice through the wing surface and create that linear plot of pressure distribution on the wing. So to do that, we're going to go to Data, Extract Slice Prototype. So this is a little bit of an awkward phase in this alpha build that we've built so far. We're playing with a new way of extracting slices. So instead of going through our typical slice dialog, we're going through here. So this is, again, a prototype. We're hoping to be able to merge these and make it feel like one operation. But again, this is part of our alpha prototype. So I know that I want to do a slice at -2.2 in the Y direction, and again, only from wall 9. Wall 9 is a surface zone. So I'll go ahead and hit extract, and then we'll do another one at +2. And you can see that we have 2 more data journal entries here. And let's just go ahead and turn on the mesh so we can see those. Turn it off on a couple other objects here. To do this, I'm right-clicking. Okay, and so now we can see our extracted slices. So to put these in a line plot, we'll just create a new frame, flip to XY line, and I want X versus pressure for, let's pick one of my slices. Now this still uses the term zones. We're going to be updating this dialog to use the term parts eventually. That work is actually in process at the moment. So by the time you're able to get your hands on this build, we'll be transitioning from zones to parts for that dialog. Okay, so in this case, I now have a line plot that represents this extracted slice. And if I animate through time here, well, you can see nothing's happening. So in order to get time to work across both of these frames, we'll go to frame linking. We'll say link solution time, apply settings to all frames. And you can see now that as I animate through time in my XY line plot, this plot is updating, but this one still isn't. So again, why is that not updating? It's because this line map that we're looking at is referring to a specific zone. So again, think of a zone is at a specific time step. So we're looking at the slice that it was extracted at a very specific time step. If we want this to be transient, we'll right click on the source data tab and we're going to select parts, and let's select our slice that went through wall 9. And now as I animate, you can see that update, and let's add our other slice. So we'll just copy the map, give this a different color, and assign this to my other part that I selected. And now we can animate through. I have a time step skip here, so you can see that we've only done this interpolation and extraction for every 10th time step. Let's go back and do every time step. And you'll see down here on the bottom, we're animating through time. And again, as we're animating through time, the linear interpolation is occurring, the slice extraction is occurring at each time step as we go. So I say, okay, well, now I want to just jump to the last time step. We've skipped doing the linear interpolation and extraction at all these intermediate time steps. So I've got to a good looking layout, a good looking solution very, very quickly. And again, just to show that we can save and restore this. Let's save this layout, save it as untitled. Do I want to replace it? Yes. And we'll do a new layout and open this back up. And you can see we're right back to where we were. Okay, so that's the first demo. So we showed you the data journal, explained the deferred data operations, and showed a couple of the updates that we've made, linear interpolation and extract slice. All right, let's go into another example. This is a simulation data that came from Convergent Science. It's an internal combustion engine, and our goal here is to understand the average temperature on various parts in this data set. So what we've done here is we're looking at the average temperature on the cylinder head, average temperature on the piston, and also the average temperature within a specific radius of the spark plug. So this is going to take us through a couple other data operations, such as integrations, altering data, and extracting regions, which is a new concept that we're introducing in this alpha. So again, we can animate through here, and you can see how the data all animates together. So we'll go through these steps and show you how that works. So let's bring this back. We'll do a new layout and load the internal combustion data from Convergent Science. So this is 145 time steps of this data. All right, so the first thing we'll do is let's show the temperature value on the head and the piston. And we're going to deactivate the liner here so we can see inside as well. And the first thing we'll do is we'll go into the Analyze, perform integration. We're going to do the average of the temperature. And we're going to integrate over parts, and let's integrate over the piston and the head. And we want to plot these results, and I'm going to give it a name of average temperature. Okay, so now we have a plot of the average temperature at our first time step for both of those items. And let's just jump to the final time step, and we'll do a view fit. So that's Control F. So now you can see, our average temperature at the beginning and average temperature at the last time step in this simulation. And If I want to just get a quick overview of these, let's just go every 20th time step. So again, this integration is now occurring only at the time steps that I've visited, and I can do another view fit. And so you can get a very rough idea of what's going on. Well, now let's say I want to understand what's going on within that certain radius of the spark plug. So in order to do that, I need to compute a new variable called radius, and I have that formula already listed out. So that's square root of x squared plus y squared plus z squared. And then of course we're, to get it centered around the spark plug, we're adding a little factor there. And then we want to do this only through the cell data. So that's the volume data, because we really don't need the radius on all of our surface data. So we'll just hit compute. You can see that occurred very, very quickly, because that computation only occurred at this one particular time step. And we can again see a record of what we've done. And if we said, okay, well, we really do want radius on some other object, we can just simply edit this and then hit the apply button. Okay, so the next step is we want to extract the cells that are in the range of that radius that we were looking at. So we're going to do an extract region. And in this case, we want to be within 2 centimeters of the spark plug. So I'm going to say where radius is less than or equal to 0.02. And we want to keep cells that match this criteria. And again, we want to extract this only from the cell data. So we'll go ahead and hit extract. Oh, looks like little typo there. Okay, so the extract region is successful. You can see that I have a new part here called extracted region, and again, a new entry here in the data journal. So let's come back here to this 3D plot and take a look at that new part that we created. So we're going to show that part, and because it's volume data, by default, we don't show the surfaces of it. So we'll go into the surfaces tab, right click, and say boundary cell faces. And let's also turn on translucency. And you can see that this region extends up into my intake and exhaust, and I don't want that. So let's take a look at how to get rid of that. So I want this to be limited to the height of the cylinder head. So let's just do a probe. And we can see that the Z value at that probe is 0.0017. So let's just copy this and come back over to the data journal. And I'm going to update the criteria here to say, and Z is less than that Z value that I just copied, and hit apply. And you can see now that that region is constrained to the below the head, just like I want it. So again, you can see here that we're trying to make Tecplot 360 easy to recover from minor mistakes and make modifications to your data set. All right, and now finally here, I want to understand the average temperature in this region. So we'll go back to perform integration, and I'll select this new part. I don't want to hit plot results as, because that will create a new frame. If I just hit integrate here, it will add a new integrated zone to my data set. So in the line plot, we will go back into mapping style, and let's just copy this map, and we'll change the definition to point to this new integrated region or integrated value. And let's make sure that we give it a different line color. And it looks like we need to give it a different symbol color as well. So you can see that that integration and this extraction all occurred just at this one time step. And then if I want to go back to the beginning, again, we're doing it at every 20th time step. So we get a nice, good overview of what's going on in this region of data. And then let's say, okay, well, I know that the interesting stuff is really happening between, say, 0 and 100 degrees crank angle. In this case, say 0 to 100, and we'll say every time step. in that region. And so now we're getting a much better view of our data.
Scott, a question came in while we were giving some of these demonstrations on the
Sure.
parts work. So the question is it possible to import or export the data journal operations apart from saving a layout?
That's a great question. Right now it is not, but that's something that our development team has thought about because it really does make sense to, I mean, if we think about being able to apply this work to a different data set, right? You know, a layout always starts with a read data set command. And you may want to load a data set and then apply the journal. So right now, no, but it's something that, that we've certainly thought about. So I appreciate the question.
Great, thank you.
Okay, so now we have this this layout that looks, you know, pretty similar to the one that we initially created here, and you know, we have very similar steps here as well. So you can see that lots of interesting capabilities in this new build of Tecplot 360. Now, this is very much an alpha, right? You saw some dialogues that you know, like the slice dialog and the extract slice prototype don't quite give a great user experience yet, you know, so we're still playing with this. And but I think that users will be happy with the updates that we've made. So we'll talk more about our direction with that in a little bit. But in this alpha, we've pretty much demonstrated all of the capabilities that have been ported to this new infrastructure in this alpha. So we've added specify equations, which is the alter data, linear interpolation, calculate variables I didn't demonstrate, but it's pretty straightforward. Integration you saw, the extract slice prototype, extract region, which is this extract region using constraints, and then of course transient line plots where you make a line map associated with a part rather than a zone. So what do we have left? Well, a lot. There are a lot of data operations that are built into Tecplot 360 that still need to get translated over into this new architecture. In addition to this list, we have other dialogues that we may want to show parts instead of zones. So this is very early on in the development stages, but as you saw in the demo, quite operational. Okay, so let's move on to the next subject, the new graphics layer. So again, the Tecplot 360 and FieldView teams are collaborating on a new graphics layer that is going to be used by both products. And we're doing this work to ensure that, you know, as hardware advances, you know, I mean, I don't know how many of you have seen NVIDIA stock price lately, but, you know, they are making some pretty significant hardware advances. And we want to make sure that we're able to be compatible with them. You also know that Macintosh or Apple machines, they've moved to the M1 and M2 chips, and Apple has migrated to using their own rendering layer called Metal. And we've started to see some degraded performance, particularly on the Tecplot 360 side on rendering on some of those Apple machines. So we're doing this refresh to improve the rendering performance on all platforms, including Apple. And then this work really opens the door and sets the groundwork for other new rendering capabilities in the future, such as volume rendering, ray tracing, oil flow, also known as line integral convolution. So our first goal in this project is to replace the capabilities that Tecplot 360 and FieldView currently have to make sure we're on good footing. And once we achieve that, we'll be able to move on to some new capabilities. So some early results. So we've done some performance testing. This was done with a reasonably old graphics card, actually, on a Linux machine, an NVIDIA Quadro card. So we took a data set that we had in-house that was this transport airplane, and we multiplied it, you know, 32 times to get quite a lot of nodes and, you know, 43 million triangles on the screen rendering simultaneously. And you can see that Tecplot 360 2023 R2 time to first image was quite a bit longer than this new alpha build that we're playing with. So, and we've done that by in this new test bed set of code that we're working on is we are working on more efficiently delivering data to the graphics card. So that's one of the biggest things that we're doing here for time to first image. You can see when plotting just the mesh on this data, a huge benefit in time to first image, whereas smooth shading, not a big benefit there. So Tecplot was already pretty efficient there. So we still have a lot of other performance tests to do, but you can see for various different plot types that we've implemented so far, we're seeing good improvement with this new graphics layer. If we go to the next plot and we look at frames per second, so this is once the data has been delivered to the card and you're interactively rotating the plot. In all cases, the alpha, that's the orange bars, the higher the bar, the better. We're seeing, we're going from about 2 or 3 frames per second with panel shading and smooth shading all the way up to 45 frames per second. So you're going to get much better interactive performance with this new rendering layer. Now this is very, very early on in the development phase. We expect that the new graphics layer will have an alpha build sometime late 2024. So quite a lot of work to do, but the team is doing a good job of collaborating together and creating a new test bed to test our performance. We're also going to be looking at larger data sets, and we're also collaborating with the graphics card providers to get a good cross-section of graphics cards that we're going to be testing against. All right, so we're going to wrap up the webinar here. So the final ask here is that the work that we're doing here is not without risk. We realize that some of the changes here are potentially going to change workflows, possibly even break workflows, and we really don't want to do that. We want to have a minimal impact when we deliver these new capabilities to our users. So we're asking for people who are willing to test these early builds. And what we've done is we've created a user forum using the user forum technology, a website called Discourse, and we're going to be limiting our early alpha tester group to about 80 to 100 people to try to limit the feedback as we're in this early phase, and then we'll invite more as the product matures. So it's really important to help us expose some of our blind spots. We have a really good test suite, and we're testing against old workflows. We're testing with new workflows, but it's really helpful to have the user community get an early view on this and let us know what they think. So if you're interested in being a tester for any of the capabilities that you saw today, you can scan the QR code. And really what we're looking for here is a cross section of users, right? We want people in aerospace industry and manufacturing industry and geosciences. We want people with steady state data and transient data. So we're going to do a bit of a selection process to make sure that we have a wide cross section of use cases and users in this community. Okay, so with that, I appreciate your attention. And again, if you have any questions, the best way to get a hold of us is through our support channels. So if you're in North America, that's support@tecplot.com. If you're on the European continent or Western Asia, that's support-EU@tecplot.com. We have staff over there in your time zone. And then if you are in other locales, you can contact your distributor directly through the link that you see there. So I appreciate your attention, and it looks like we do have some questions in the question panel pane. Brandon, you want to run us through some questions that have come in?
Yeah, so we've got a couple questions. So when is the new version expected to be released is one question we have here.
Yeah, that's a great question, and short answer is it depends. It depends on feedback from the beta community. So that's why we're really trying to establish this. So I don't want to release it until it's ready. and it's going to be ready when our users tell us that it's stable and tell us that it's usable for their workflows and that we haven't broken anything. So we are going to have alpha and beta builds available fairly soon. Our development team is doing a few weeks of what I call hardening. There are admittedly some bugs in this, and I danced around them in the demo. So I don't want to say, this works perfectly, but it works pretty darn well. So we're doing a hardening phase. So if you sign up for the beta community, you'll get access to this sooner rather than later. My hope is that we can get something out later this year.
Great. Another question. So do macro and Tecplot operations automatically get logged in the data journal?
So the data journal, right now we've done all of our testing from the GUI only. So really, we have not developed any new Tecplot commands for this, but Tecplot workflows will continue to work as they always have at this point. Macros, we haven't done a lot of testing with recording macros yet. So I think those are great questions that our team is going to have to answer.
And I guess we have one more question here too. So how many Tecplot users are there worldwide?
That's a great question. It's a hard one to answer, but we know how many licenses we have. Some of those licenses are single user licenses, so we always assume that's just one user. We have a lot of network seats, right? So that's a shared license, and we make an assumption that there are about 5 users per those, and so we think that there are about 60,000 users worldwide. But that's based on some formulaic guesses.
All right, thank you. And that looks like it on the questions that I see here.
Okay.
If anyone has more questions, feel free to send them in real quick here, but thanks for all the questions, everyone.
Yeah, and it looks like, Brandon, you did reply to a number of questions. I don't know if everyone can see these, so let me just run down a couple others that came in. What about Apple M3 chips? Yeah, I mean, Apple Silicon in general, we're going to be supporting. So as Apple continues to pump out new versions of their chips, yes, we'll be supporting those. I see one about do we plan to add rectangle scatter shapes? We have squares, but we don't have rectangles. We also have cubes in 3D. So rectangle not on the list, but through additional conversation with Brandon, who's the product owner for Tecplot 360, that's something that we could potentially add to our list. I will point out, if we go back to the graphics timing, one of the other areas in performance is, say, spherical scatter symbols. I know that this is really important to people who are computing simulations with lots of particles. Like in this converged data set, we do have some spray data, which I'm not displaying, but if you have hundreds of thousands or millions of particles, this new rendering layer should help with performance there. We've done a little bit of benchmarking, but haven't used any realistic data sets yet. So we're making improvements there as well, as far as rendering goes. Okay. Well, with that, we're going to end the webinar. And if you have any other questions, please, again, if we didn't get to them today, we'll feel free to send an email to support@tecplot.com, and we'll of course follow up with people who ask questions during the webinar. So I appreciate your time. Thank you very much.